So today we're going to move into a new chapter, chapter 8, which is about rational functions. And the first section in that is called inverse variation. What we need to understand from this section is pretty basic. If you have two terms that have a constant or fixed positive product, when you increase one value, then the other one has to go down. Okay, so what does that look like? Suppose you need to fence an area of 100 square feet. How can you do that? Okay, well, the easiest way to probably do that would be pretend that's a square of 10 feet by 10 feet, because then you have 100 square feet. But let's say that you need to make it longer. Okay, if you make it longer, then it has to be not as wide for the area to remain the same. Does that make sense? Because we got longer here, that means that this distance got to be shorter. If you wanted to make it less wide, then it needed to be longer. So you can still have all of these different shapes with an area of 100 square feet. That if that's the fixed product, then an increase in the length results in a decrease in the width, or a decrease in the length results in an increase in the width. Okay, so that's kind of a more complicated way of saying inverse variation here. Okay, and that's what this lesson's all about. When you have two quantities that vary inversely, as one quantity increases, the other quantity has to decrease proportionally. Okay, so if you have a fixed product, so x times y is equal to some fixed product k, then you could rewrite that. If you solve this equation for y, you'd divide both sides by x, so you'd have y is equal to k over x. This formula right here represents what's called inverse variation, and it's the basic principle behind rational functions, which is what this whole chapter is about. Okay, before we move into just seeing some basic inverse variation problems, we need to review something that we covered way back in the first semester called direct variation. So when we have two quantities with a fixed quotient, okay, so y divided by x equaled the same thing. Instead of y times x equaling the same thing, y divided by x equaled the same thing. Okay, that was more commonly seen as y is equal to k times x. Again, if you solve this for y, you would multiply by x. So this is how you would get this. This was direct variation. Direct variation formed a line that went through the origin. It was a basic, just line with a slope of k, whatever k is. Okay, the graph of this we'll get to in a later section. All right, but what does it look like? Okay, identifying variations. In each table, is the relationship between variables direct, inverse, or neither? If it is direct or inverse, then write a function. Okay, so I have first an example problem for me to talk to you about. Okay, notice how x is increasing each time and y is decreasing each time. Okay, so that right away tells you that it could be inverse, because inverse is as one goes up, the other goes down. So this could be inverse. So to check that, you have to multiply them together. All right, just to review, and maybe we need to write this over here. So with inverse, we know that x times y equals the same number k every single time, and with direct, y divided by x equaled the same thing every time. Okay, so that's what we're checking here. So we see one goes up, one goes down. That could be inverse. If they equal the same thing each time, it is. So 2 times 15, well, that equals 30. 4 times 7.5, well, that also equals 30. 10 times 3, 30. 15 times 2, also 30. So they equal the same thing. This would be that value of k. So now for us to write the function, okay, so this is how we test to see if we have inverse or direct. Then we go back and we write the function, which means we solve for y. Y is the function of x. Okay, so y is equal to, this is inverse, all right, first of all. Okay, we have the same number, so we know it's inverse. So again, if you were to solve this for y, okay, you'd have to divide by x. So you have some number k, which we figured out, divided by x. So that's all you have to do. Y is equal to this number k, we just found, 30 divided by x. So it's inverse variation. This is the function. All right. So 3 more tables down here. All right. Right away, you can pause to see if you can try to do them yourself if you want to. Otherwise, I will be going through them right now. Okay. So very first one, x is increasing, y is also increasing. Okay, so that could be direct. That can't be inverse because they're not doing the opposite thing. That could be direct. We'll see. We got to test it. So we have to do y divided by x. So you'd have to do 8 divided by 0.2. Okay, so if you don't know what that is, bring your calculator over. 8 divided by 0.2, okay, that equals 40. All right. Again, y divided by x. So now you have 20 divided by 0.5. 20 divided by 0.5. Oh, look, that's also 40. 40 divided by 1 happens to be 40. 60 divided by 1.5. You don't believe me? Well, it's 40. Okay, so we have the same thing each time by division, so that means that it's direct. So then if we, again, solve this for y, we would multiply it. Okay, so our equation now, y equals 40x. Okay. On number 2, we see x increasing, we see y decreasing. Okay, so that tells us it could be inverse. So now we multiply them together. Okay, so 40 times 0.2 this time, and you get 8. 16 times 0.5, you get 8. 8 times 1, 8. 4 times 2, 8. Okay, so we got the same thing. It's inverse. And so it's just y is equal to 8 over x. Okay. Sorry, I just realized you couldn't see my calculator there. And then on number 3, x is increasing, y is decreasing. Okay, so that tells us it could be inverse again. But now we got to check it. So inverse again, you multiply them together. So 40 times 0.5. Okay, so here you get 20. Okay, 1.2 times 12. Okay, 14.4. So right away you can stop because you didn't get the same thing. Okay, so this is going to be neither. And you don't need to write an equation if it's a neither. Okay. Finally, determining whether you have, determining inverse variation. It tells you you have inverse variation. That's what this says here. X and y vary inversely. X equals 4 when y equals 12. Okay, what function models the inverse variation? All you have to do on this one is remember this. Inverse variation, multiply x and y together to get the value of k, this constant of variation. So you know x and y, so multiply them together. 4 times 12 equals 48. That's what k is. And then you just write your equation, which is y equals a over x. So y equals 48 over x. Sorry.